We are going to talk about how a model can listen to the rain to predict landslides. Rainfall-induced landslides in particular is caused when there's prolonged or heavy rain, which causes soil particles to actually lose their cohesion. And this causes instability in the slope and it eventually fails.
Okay, and this is not only dependent on the rain, I suppose?
No, it's also dependent on other terrain characteristics, like maybe how steep the slope is, what kind of soil type is there. But the rain is the main triggering factor.
So why do you want to listen to the rain?
So the idea is that right now, when rainfall-induced landslides are being predicted, they typically compress rainfall, which is a very continuous process, into a single measure. So to put that into perspective, like let's say you have rainfall occurring over multiple days, which means that you have multiple data points here. What is typically being done right now is that they look at just rainfall at one point in time, maybe the cumulative rainfall on, say, day 15. And then if that exceeds a specific threshold, which they determine based on past landslide events, as well as the rainfall that's being associated with those events, they then issue a warning for the landslides. And they neglect all the other data points of like the rainfall in the previous days. So the intuition is that what if these other data points actually contain information that could help us better predict the occurrence of these landslides?
But when you say listen to the rain, are you actually putting microphones there to listen to it?
No, we're not. So the idea is that we are actually feeding this rainfall signal like into a neural network that was specifically designed for natural language processing, but also widely applied in speech recognition. Because let's say when we talk to Siri, like our voice is like a signal that Siri reads. And then like we thought, what if we applied this concept to rainfall as well in predicting landslides?
And what is the advantage?
The advantage is that this specific neural network is actually designed to handle long sequences of data. So they can actually take into account like all other data points and not just like a single data point in time.
And you applied that to a certain region?
Yeah. So I applied this modeling framework to specific regions in Vietnam where we had rainfall as well as landslide data. The conclusion that we had is that considering the rainfall signal in this specific neural network framework in conjunction with other terrain characteristics that have a great influence in determining whether or not landslides may or may not occur, actually led to better model predictions relative to considering only a single aggregated measure of rainfall in time. So this is the output of my model. What you can see is that my study area has been partitioned into slopes, and each slope is associated with a probability of failure every single day. And from this alone, you can actually see which slopes are more prone to failing as compared to others for a given day.
And the rain, so how do you measure the rain? Is this coming from satellite information or do you have measurements in the ground?
So for my specific study, we actually used satellite measurements of rainfall. But I have to say right now that my study is actually it's not exactly true prediction, because what we did was we actually used observed rainfall. The next goal, or rather the next step, would be using forecasted rainfall. So predictions of rainfall in future to actually see if those predictions of rainfall can correctly predict past landslide occurrences. Yeah. And then that will be the true landslide forecasting.
Okay.
Yeah.
So let's say I'm a person living somewhere where rain is happening. There's a lot of rain falling and there are lots of slopes. What is the benefit for me?
The hope is that such a model could lead to more accurate predictions, because it could go a few ways, right? You can have a false alarm, or you could also have a false alarm in the sense they say that a landslide might occur when it actually doesn't. Or worse still, you could also have a prediction where they say no landslide, but then a landslide occurs. So hopefully we can minimize such false alarms in that sense.
Well, thank you very much for this interview.
Thank you for your time.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.